another A-level computer science video with me, Mr Goff, for MrGoff.com. This video will run through the solution to the stacks problem that was posed at the end of the last video. In this video, I'm going to run through the solution to building a stack class with attributes for stack, pointer and max size, methods for pop, push, peek, is empty and is full, and then we're going to use that class to create a memory game which uses a stack where each turn the computer randomly selects a colour from red, blue, green or yellow, which is added to the stack and displayed to the user. The user then has to input the colours in the reverse order they were given, so the one they've just seen as well as the ones they've already seen. The game should end if the player gets one wrong or if they get the list right when it's at its maximum size. To do testing, you might like to reduce that to something around 4 rather than the 10 I'll be putting it at. As an extension, you could implement peek as a way for players to have a free guess and maybe count how many free guesses they get. The constructor defines a stack, its maximum size and pointer. The value none is a placeholder in Python, so we can have a variable that will store the pointer to the head of the stack, but that currently has no value because there is nothing in the stack. Technically, we could implement this without the need for a pointer using Python's built-in pop function, which by default removes the last item added to the list, but I've included a pointer so that it looks more like a stack that we've implemented. IsEmpty is a method to check if a stack is currently empty. It would be used before attempting to remove an item from a stack to ensure no error is received. All we're going to do is check if the length of this stack is equal to 0. You may notice the use of the word self here again. IsEmpty self means if this instance of a stack, because we might have created more than one stack, has a length of 0, then return true, otherwise return false. IsFull is a method to check if a stack is currently full. This method would be used before attempting to push an item to a stack to ensure no error is received. Once again, we pass in self because we want to know if this particular instance has a stack that has reached maximum size. Push is a method to add an item to a stack. Before attempting to push, we check that the queue is not already full. If we add something to the queue, then the pointer must be adjusted to point to the location of the last item in the queue. If the queue was currently empty, then the pointer would have currently said null and now needs to say 0. Otherwise, it needs to be incremented by 1. Pop item is a method to remove an item from a stack. Before attempting to pop item, we check that the queue is not already empty. If we remove something from the queue, then the pointer must be adjusted to point to the location of the last item in the queue. If we've popped the last item off the queue, then the pointer should now say none. Otherwise, it should be decremented by 1. Peek is a method to look at the item on the top of a stack without removing it. This can be achieved by referencing the item the pointer identifies. So we're just going to return self.thisStack, self.pointer, so the item that the pointer is pointing to in the stack. In order to implement the game we're planning on doing, I'm also going to set up some getters for the stack itself and the pointer to the top of the stack. If we look at this getStack method, all we're doing is looping through the self.thisStack array from the end back to the start. Now let's try making some use of the stack to see how it works. So first of all, I'm going to create an instance of a stack and store it in the variable game1. You can see that when I print game1.isEmpty, it returns true because the stack is currently empty. I then push to it, blue, yellow, then red, and I claim getStack, and it reads them back off for me in the reverse order, that is, like a stack would do, from the last item added in back to the first, so red, yellow, blue. I've then called print game1.getPointer, and you can see that it is in position 2. Blue would be in position 0, yellow in position 1, red in position 2. I then try isEmpty again, and we now get false because we know there is stuff in our stack. Game1.peek reveals red, because red is the next thing that would be pulled off the stack. And if I do get stack, you can see that once again it still has all the same items in it. Nothing was removed when we used peek. When we say print game1.getPointer, it's still showing them level 2 because it is pointing to item 2, which is red. And then when we say pop item and get stack, you can see that now the stack is only 2 items long. When we say what's the size of the pointer now, you can see that it is now pointing to item 1 in the array. When we go through both items and pop them, we'll have emptied our stack and there'll be nothing left in it. As we will regularly choose a random colour, I've made this into a subroutine. This requires the importing of the random module at the start of the program. Here, I'm simply saying that colour will be a random choice from a tuple that contains blue, green, red and yellow. So each time it will return either blue, green, red or yellow back to the main program. Now it should be noted that the main point of this next task is just to utilise the object stack that we've just created in an actual game. There's many ways you could solve this. This is just one rough way that I chose to demonstrate its use. So I've broken it into sections, and to begin with, we've got the start of the game where we set up the game ready to go. To start the game in this instance, we create a new stack. We call choose color to get a new color. We push this color to the stack, and then we output the color that we've just chosen. I've imported sleep and used it to crudely make it such that the color scrolls off the screen after a second, so the user can't just see what it was that was written there when they try to enter the stack. This does require importing the time module to ensure that the command time.sleep1 will actually make the program stop for 1 second. In the main game loop, I use a flag for game over. While the game is not over, we create a deep copy of the object. This requires importing copy. If I had just said temp game equals game, what actually happens is rather than creating a new object with the same attributes and methods, what it does is just create another link to the same object. We need to use deep copy so that temp game is an actual copy that is separate entirely from game. Using the copy, we pop items from the copied stack and ask the user what they are. If they get it wrong, the game over flag is set to true and the stack is output, and the loop to pop items from the copied stack is broken using the break command. Once the stack has been guessed or the user got one wrong, we check the stack is not already full. We also check it's not already game over. If this is the case for both things, we generate another color and append it to the original list. When the loop starts again, this expanded list is copied and the process starts again. If the stack is full, then the user is told that they win and the game over flag is set to true, so the game stops. That brings us to the end of this video walking through a stacks example using object-oriented programming. Join me again soon for a new video on queues. Use the resources at mrgoff.com to help you revise computer science. And until next time, it's bye for now.